The Egress Gateway routing feature as part of Cilium allows you to define a exit route for your traffic from your containers that is known to the rest of the network. This is particularly useful when you need to know the IP address where traffic's coming from, in the case of things like web proxies, or if you're using more traditional firewalls in your environment as well to kind of define or set boundaries across your data center. In Cilium 1.16, there have been enhancements so that you can get extra observability for that egress traffic path itself. So let's just dive into a few of those features first and foremost. So first, I'm just going to check which egress address is being used inside of my environment already today. So this is already an existing feature and command. I'm just going to check this by looking at the Cilium agent that's running on one of my nodes that's been marked for egress traffic itself. And we can see that the IP address being used is .4. That's the IP address of the egress node itself. And then .42 is actually the egress IP that we're using for any traffic that goes through our environment. And we can see we've got a couple of source IPs that are already in use as well. So these are two pods that I have running in my environment, and they're trying to get to this external destination side as well. And that's defined by my egress policy that's in place today. So we'll go ahead and clear that. So the first one is the introduction of NAT statistics inside of our state database. So we can now do the Cilium command. The Cilium command has been updated, so it's Cilium-dbg, just to differentiate between the Cilium command that you can run locally on your machine. At the moment, inside Cilium agent, you can just use the alias of Cilium as well still. And now we can see we've got a number of additional statistics that are recorded. So we've got that egress IP address here. We've got the remote address of where it's going to and the port numbers that were being used for that, and how many have been counted inside that database as well. So essentially we're using network address translation that uses a port to map the connections through that single IP address to the remote destination. And then for the return traffic, it will then translate that back to the backend ports as well. The reason why we now have the statistics inside of the environment is so that you can look at the exhaustion of a particular node as well. This particular statistics are also exported as a metric that can be scraped by Prometheus or other observability tools. And that is called the NAT underscore endpoint underscore marks underscore connection metric. And if we look at that in particular, we can see we've got one for both IPv4 and IPv6. This metric that is exported is based on a percentage, and that percentage is worked out by the available ports that are available when you create your egress, the max number of ports available, divided by what's being used. So essentially, if you see that value hit 1, it means 100%, which then means that the all of the available port range has been exhausted on that node, and then you would start to potentially see some assignment problems and traffic problems going through that node. The way to alleviate that then would be to have multiple different egress nodes inside of your environment that with different policies in place for different exit points, depending on the network that you want to go through. Or if you were looking at Isovalent enterprise facility, and then there is a egress HA feature as well, which could alleviate that. So moving on, let's look at some of the enhancements that have also been made in Hubble, so that you can also search through that data as well. So the first thing that we're going to look at is some traffic going to a particular through an egress node, and we're going to look at that full data flow, output it to JSON, and then just using JQ to format that for me as well, because there's some additional fields that have been added into that Hubble output. So the first thing that you're going to notice is that when the traffic is a flow that goes through an egress node and has been translated using NAT, we now have the source underscore xlated, short for translated, field. So we can see here it's been translated to my egress IP. If I scroll down, we've also got the node labels feature, so I can now actually filter based on the node label of egress, or again from particular availability zones inside of my environment. Then if I go down a little bit further, we can also see for the traffic that travels or transverses through an egress node, we also get the interface details as well that come through. So all of my nodes today use ETH0 as that node. That means we do have the ability to filter on the node label, the interface that's available. We also have a SNAT-IP argument that can be used as well. So I could actually look for all traffic which is translated through this particular IP address inside of the environment. Okay, so let's send some more traffic through my environment. And this time, oh, so I've just missed the F there on that one. So let's try that again. There we go. So I'm just going to send some more traffic using those two pods in my environment to the external IP address of 172.18.0.7. And now we're going to use a slightly different filter. So we're still going to filter just on the node label for this particular egress gateway in my environment. But basically, we're looking for all traffic which has a static, a source NAT IP address ending in .42. And now we can actually see those two pods. So we've got the Y wing and the X wing as well. And we can see that they're all going to this port. And then again, I can start to filter and dive into that more. Or we could actually look and filter this traffic using the new Hubble common expression language filters as well, if we wanted. And that just wraps up some of the egress traffic path observability enhancements that we have in Cilium OSS 1.16.